Sir,
No, the
okay.
participant is.
All the participants are joined.
Okay. Just wait for
So,
the another 5
yes, we
minutes,
will.
madam.
No, we will start, sir. We will start the first candidate. Sir, timing for them for presentation.
Madam, 10 minutes in the presentation. Each participant
Okay.
have the
Yeah.
10 minutes.
I request. Yeah, I'll inform the participants. No. Okay. Dear participants, we can start the session. So I request the first candidate to present your slide.
Samuel
Sir,
Alex Schools.
Hello. Screen visible?
yes, it's visible.
Hello.
Yes, visible.
Hi. Uh, my name is Samuel, and I'll be presenting a paper on leveraging jetpack tools for contextual religious applications. So, I'm a student at MCA at Rice University. The paper. So, this is the we'll move to the second slide. So, during COVID-19, we saw an increase in usage of still media for religious services. But at that time, in the Malankara Orthodox Church, still many books were all printed, and there was no proper digital content for all this. Different data were all broken and kept available in different sites, but not consolidated in one single place. So this led to a need for a consolidated framework. So that's where this application came about. So the idea was to create an consolidated place where all prayers are available in multiple languages and for different accessible, so that there's no issues with readability and understanding. It also had to integrate, and there is no mistake that cause any issues during prayer service. Along with this gave a good opportunity to see how it can perform when a large group of people use the application, so that there's no performance issues. So methodology project, while we had since it was an online project, we were able to get live data from users. Once we created the application and we published it, we could see how users interacted with the app and understand what are their behaviors and what are features they found useful for the app. And getting a wide array of users that the app on different hardware specifications, so we can understand how well it can perform on high end and low end. So the application was built using Jetpack Compose and follow OCM architecture. And we use data store for preferences and Firebase storage for on content storage like audio files. All other content was stored as JSON and stored locally on the phone, so that there is no delay in accessing the prayers. So even if there's a network issue, uh, at first we conducted a study with students inside the campus only, and once users supported the app was very useful, we released it publicly to other people as well. And we measured how it performs with different users on different devices. Things like how much time it takes from cold boot, hot, quick rebooting, and how much it recomposes each component in the screen as well. So we found out that the app was very successful. It got adopted by many people. We got 13,000 downloads within 12 months of development. And different age groups, especially the elderly people, found the app very useful. They reported high usages, and surprisingly, the elder age group found the app useful compared to no, printed media. They found that the readability was much better than in printed media. We assumed that in the beginning that they will not be liking it because they are used to reading from printed media. The fact that it had multiple language features also made it very accessible. Uh, and even with so many devices, the app performed quite well. There was very less lag, except in certain scenarios where the app was found to not respond. So the developing the app in Jetpack Compose ensured that the app had performed natively, which is one of the reasons why we decided to go with Jetpack Compose over Flutter or React. Then following the best practices, modular architecture ensured that the development is smooth and can be easily scaled as well. And things like the font sizes and navigation were especially appreciated by different users. And it showed that even though we switched to a digital media, it was still useful for people without too much friction with printed media. And to ensure that people are not distracted, um, there was not too much clickability or anything, so that people focus on the prayer service rather than on the phone or the app. So this study showed that we are able to successfully use digital media in prayer services by focusing on user experience. We ensure that the feel inside the church is also not lost. It, uh, this so right now we have only focused on Android. So in future development of this application, we can consider building for iOS as well, and maybe even web development. And right now there is no admin page, so to speak. So even that would be useful. Thank you.
Very good, Samuel. Nice presentation, actually. The work is also good, I find. So, have you compared with any other app which is related to the same technology? I didn't get actually what the technology you have used here. Then is this particular app is in use now?
Yes, it is currently in use. I
Okay.
have compared it with around 3 other applications that I found, but none of them give the same features as mine. But they are
Okay.
what I found is that they like one meditation app, like in churches, and then one Quran app, and then
Okay.
one other app I found. So they focused a little more on performance rather than on the content so much. Or they were also one of the apps that we found was also focusing on the social aspect of the app. So they checked. Most of them were also built on React or Flutter.
Okay.
So performance-wise, also we compared with the other apps and found that it could perform better. And even ratings
The
were
only
different.
thing, this is the as it is a research conference, you could have mention or you add you could have added that comparison chart or something. It will be great actually. Anyway, no problem. But you have compared, right? Always
Yes,
in the
yes,
research contributions, we are supposed to add the comparison results actually. At least one or two graphs should be there. That is the ethics of research presentation. Anyway, it's okay, good. It's now it is in use, right?
yes.
Yes. Okay, ma. Thank you so much. Thank you. Now I request Glory Reggie, the next candidate.
Yes, ma'am.
Yeah, you can. The title is AI powered news summarizer and bias detection.
Yes, ma'am. I'll
Yeah.
share my screen. Um, is my screen visible?
Yeah, says what.
Okay, so uh, good, good afternoon, everyone. I am presenting my research work titled Newsline's AI, an AI-powered news summarizer and bias detection. So, this work was carried out as a part of a research at the Department of Computer Science, Christ University. Uh, our goal is to address a very relevant issue today: how people consume news without knowing it is biased, sensationalized, or reliable. Unlike fake news detection system that classify content as true or false, our work focuses on analyzing editorial bias, tone, and most importantly, providing transparent and explainable evidence behind every score. So, problem statement, we have three problem. First is information overload. There are hundreds of news articles published daily, and readers don't have time to verify credibility or compare perspectives. And second is hidden ideological bias. Bias is often subtle. It exists in words or choices, tones, and framing, which influences readers without them realizing it. And third problem is sensationalism and fragmented tone. Many platforms use emotional language and exaggeration to attract attention. Also, existing tools are fragmented. Some do summarization and some detects bias, but there is no unified system that does everything transparently. So our research objective is based on these problems, and we define four key objectives. First is the transparent bias quantification. So we wanted a system that doesn't just give a score but shows exact mathematical proof behind it and their frequency and their contribution to the final index. And second objective is multi-vector bias classification. We classify bias across six dimensions: political, religious, gender, racial, economic, and loaded language. And third objective is sensational detection. We detect exaggerated and emotionally manipulative content. And fourth is accessible and interpretable interface. We designed a simple real-time dashboard with features like text-to-speech for accessibility. So our methodology is, our system follows a modular pipeline architecture. So step one is data acquisition. We collected live news API from global sources. Uh, Live news via news API, JSON payload retrieval, and global source coverage. And step 2 is pre-processing. We clean the data using regex, HTML removal, and white space normalization. Step 3 we have is NLP heuristic engine. This is like most important part of our system. It consists of four modules: bias detection, sensationalism detection, fact extraction, and tone classification. Step 4 is dashboard output. For dashboard, we have used React.js and DOM native causes. Uh, we use React.js to display bias scores, tone, and insights. And step 5 is text to speech. We just added browser based text to speech with zero latency, and it works offline. So, we'll know how bias detection is working. So, to calculate the bias score, first step we are using is a vector keyword library. We created dictionaries for all six categories. Each contains targeted lexical indicators for domains. And step two is headline double weightage, because mostly headlines are like given more, more uh, manipulated. So we have given double weightage to the headlines. Step three is bias score calculation, density scoring. So we compute the bias score with this formula, which is bias density is equal to trigger count by total word count, and we are determining final bias score by density into 10. and we are normalizing it to 0 to 100% index. And step 4 is tone classification. We classify tone into positive, negative, neutral, or inflammatory. So here we can see the risk classification, how we have uh, divided it. 0 to 20 is minimal bias, 21 to 40 is low bias, 41 to 70 is medium bias, and 71 to 100 is high bias. And results and key findings. Um, we have 6 bias vectors: political to local language, 4 NLP modules, 0 millisecond text to speech latency, and 100% auditability. Every bias score is explainable with exact trigger words, their frequency, and we successfully analyzed bias across all 6 categories. 4 analysis modules working together, fast and lightweight system. Unlike existing tools, we built a complete pipeline from data collection to visualization. Here you can see the trigger detection rate by bias vector. So these are the biases which we have defined in our code: religious, racial, gender, and economic, political, and local language. So this chart is detecting the trigger by bias vector. So loaded language has the highest amount of accuracy in detecting the biases, and religious has a low amount of accuracy, only 62. And for discussion, a key insight from our work is that trade-off between transparency and complexity. More advanced AI models are black box, but our system is fully explainable. This makes it more trustworthy, more suitable for media literacy application. We also have some limitations that we cannot detect bias by omission. So, and context blind racism. Context understanding is limited and it depends on predefined keyword dictionary. And future scope we can include hybrid LLM integration, historical author domain tracking, bias by omission detection, and multilingual bias dictionary. So this is the UI of the app. So here you can see the bias index. Here it is the news and source credibility. Here we can see the how 6% bias index is showing and detected level is minimum. Overall tone is neutral. We are also checking the sensationalism. Risk level is low and detected factor is also shown as secret word. And we also have listening to summary option, text to speech. So to conclude, we developed a transparent and interpretable AI system. It not only detects bias but explains it with proof. It integrates multiple functionalities into one platform. So to conclude, this does not just tell users that an article is biased. It shows exactly how that bias is constructed, making news consumption more transparent and informed. So yeah.
Glory,
Yes,
able
ma'am.
to hear me? Yeah. Go to the last slide, the conclusion part.
Okay. Yes.
Just in the second point, right? The system answers not only is this article is biased. So really, it's your system recognized all these things. The proof what you have mentioned here.
Yes, ma'am. We have included a dictionary of
Okay.
biases words. So
Oh,
it shows all the biases, like you can see here: political, religious, gender, racial. So all these biases, it is getting calculated here. We have implemented a mathematical formula which is getting
okay.
calculated. So if word count,
Again, in your the paper also, there is no comparison chart or results is not there. You didn't mention anything, it seems. Have you
yeah, I
mentioned
haven't
any
done any.
comparison? Yeah, yes, I can see. Show that slide.
Which one?
Mm. This is the step you did. So what I'm asking is,
Yeah.
so the same. Usually, it's an yeah, we can say it's an ethics or something. Like always, a researcher should show or compare with the other people those who have did the same work, and you have to depend the work actually. So you have to your
Okay.
results always should be compared with the previous research, right?
Yeah, like
Only that
existing
slide is.
systems,
Mm.
I researched about existing systems. Like there were existing systems that were just calculating the fake news, and there were existing systems that was
Hmm.
calculating bias. But there was not a system who was which was doing all the things like
Okay.
summarization, bias detection.
Okay. Anyway, the work was really good. Very nice, ma. Thank you so much.
Thank you.
Now I call upon the next candidate, Thomas Dennis.
Yes, ma'am.
Yeah.
I'll share my screen.
Yes.
So, good afternoon, ma'am, and good afternoon, all present
Natma.
here. So, imagine a AI reading a product review which says that the expensive phone which I bought right now just dies in 3 hours. The model, a standard model, will read the word, they will detect the word loud and take it as a positive review, even though it is sarcasm. My name is Thomas Innes, and from Christ University, and my works basically shows about sarcasm detection on cross domain using the distributed model. So sarcasm undermines sentiment analysis. It is also accuracy killer. So imagine an entrepreneur is trying to get his product review. When there are sarcastic statements, it will come as a positive statements, which will affect the uh, product growth. And for to check the sarcasm across different platforms, he has to, there is no specific sarcasm detection for a particular platform, and that is where my research focuses on. So what generally happens is that right now a perfectly trained model which particularly works on a Twitter, as if imagine it as an accuracy of 92%. The accuracy drops from 92 to 71% when it is switched to a different platform like Reddit, and that 21% gap is what I is a domain gap, and what my research that's what my research is trying to fix. So the objectives are the to find out how different specific slang impact the model accuracy, and for this I implemented the Distilbert model, which is a version of BERT which is created by Google. BERT is actually a very expensive and large model, so I took the a smaller version of Distilbert, which is created by Hugging Face Transformers. So what is this? So using the distilled model, why I take the main reason is that because it is 40% smaller and 60% faster when compared to the original bird, but also retains 97% of its language understanding. So for the data collection, I took data from Kaggle for the Twitter, Reddit, and Instagram. So what I did is that after taking the data, I had to clean the data. After cleaning, I gave them labels because I was using a supervising method, which where I labeled statement reviews as sarcastic and non-sarcastic. So 70% of the data set was used for training, and rest 30% was used for testing. So so after creating the data set, I trained with my model. So after training, The main focus was here is to find instead of like learning platform specific, I want the model to turn about universal sarcasm detection instead of just like for the context, instead of like just solely focusing on a single platform. So the resultant findings of my model was that the overall accuracy is 80% when compared to with across different platforms, whereas other platforms, other models tend to reduce like the percentage comes on between from 92 to 71, and the precision score is 66.67 percentage, meaning that out of three, two were accurately predicted, and the recall is 50%. So reason, even though 80% is strong, the lower recall shows that even though sarcasm is very difficult to find across different platforms, as it mainly focuses on the contextual awareness, like it can be emojis or the post which is followed up by this. So that's why it was difficult to find. That's why the recall rate was 50%. And the significant of this paper. So Distilbert is very cheap, lightweight model. So using this, I was able to look after real-time sentiment analysis on social media. So the challenge was the domain variation, because each domain has its own specific slangs, and the way the people interact with each other is different. So it is one of the main problems in NLP right now. So in conclusion, my model is getting better at detecting the sarcasm across different platforms. And for future, I would it lacks, as the recall percentage 50%, as I told before, it lacks contextual awareness, meaning imagine it's in a YouTube, and there are comments stating, and my model would usually tend to fail because it doesn't know what the video is about. That's why it lacks contextual awareness. So I would like to improve upon that, and also add larger data sets. Now I think around like I took around 8,000 data sets from Kaggle of different platforms. And also I would like to incorporate the Silbert model with other features, like to read according to the emojis or captions. So that is what my research is about.
Okay, thank you, Thomas. Nice presentation. Have you completed? You completed this work, or still you have to do anything? Because you said only 50% of the work I have completed. Seems like.
The 50% is actually the recall rate. That is because I solely focus on the text base. So, and across different platforms, it focuses on text base. It lacks contextual awareness. That's why it's 50% recall. Like I'm trying to improve it. Like through it.
Okay. Okay. Thank you, Pa. Thank you so much.
Thank you.
The next candidate, Sridhar Modi.
Yes, ma'am.
Yeah,
I'll share my screen.
we'll start.
Can you see my screen?
Start. Now you can start. Yeah, yeah, I can see it. The screen is visible.
Okay. Good afternoon. My name is Sridhar Modi. I'm from the Department of Computer Science of Christ University. Today, I'll be presenting our paper, Memory Augmented Agents, a conceptual framework for personalized AI with long-term memory. Here's a quick outline of the presentation, an introduction to the problem, our objectives, the methodology behind the framework, the results, discussion, and conclusion. I want to ask a question. When you close a conversation with an AI assistant today, what does it remember the next time you open one? The answer is, in most systems, nothing. AI is rapidly shifting from static models to autonomous, goal-directed agents. Systems that can plan, reason, and use tools. Frameworks like LangGraph and AutoGPT support complex multi-step tasks. But here's the problem. They are stateless by default. The moment a session ends, all the reasoning that happened, every chain of thought step, every preference learned disappears. This creates what we call the agentic gap, a mismatch between an agent's capability and its ability to remember. And the current workaround is that it's called prompt stuffing, which you inject the entire conversation history into every new prompt or call. And this can be quite annoying and not a full solution. It causes higher latency and inflates the token costs. Meanwhile, solutions like ChatGPT's memory feature are opt-in and shallow. Memory is treated as a feature and not as an architectural integration. What's missing is long-term memory, and that's exactly what this paper discusses. So for the research objectives, our central research question is how can hierarchical long-term memory be integrated into AI agents to achieve personalization, adaptation, and efficiency? To answer that, this paper pursues four objectives. First, we propose the memory augmented agent, treating LTM as a first-class operational resource. Then we define a structured memory taxonomy covering episodic, semantic, and procedural memory. Third, we design a hybrid storage architecture combining vector databases, knowledge graphs, and relational databases. And fourth, we establish ethical governance principles. Let's look at the methodology. We start by classifying the memory. The MAA framework distinguishes four types. The first is short-term memory, which is the LLM's context window, fast but ephemeral. Everything in it is lost when the session ends. Then we have three types of long-term memory. Episodic memory, which stores past interactions and events. It's what enables an agent to recall a specific conversation from last week. Then is the semantic memory, which holds facts, rules, and user preferences. It generalizes knowledge that makes responses feel personalized. And then is the procedural memory, which captures task flows and decision logic. It's how the agent knows how to do things and not just what it knows. Each type serves a distinct purpose. Together, they give the agent both personalization through the episodic and semantic recall and the adaptability through procedural use. The architecture itself is inspired by an operating system design. Like just as an operating system manages memory as a core resource, the MAA treats LTM the same way. When a user query arrives, the context manager retrieves relevant LTM chunks and injects them into the active context. The LLM reasoning core then generates a response using both current input and retrieved memory. After each response, the memory manager extracts new insights and updates the LTM stores. The storage layer is hybrid, meaning it has a vector database that handles semantic similarity search. A knowledge graph enables multi-hop reasoning across entities, and a relational database which stores facts with guaranteed recall. The memory is updated dynamically. The new information is inserted only if its novelty exceeds a threshold, and stale memories are pruned after 30 days of inactivity. This keeps the store lean and relevant. Coming to the results, research from Chikara and his colleagues found that the LTM integration yields 26% relative increase in accuracy, 91% reduction in the P95 latency, and up to 90% token cost savings. When we compare the framework to existing other frameworks like RAG, MemGPT, LangGraph, AMM, these other frameworks none of them offer full combination of episodic, semantic, and procedural memory across a hybrid storage layer. These other frameworks don't may also not consider ethical considerations. Our MAA is the only framework in the comparison that uh, achieves or tries to achieve all of this. Coming to the discussion, LTM doesn't just improve the performance, it changes the agent itself. It converts a stateless query response into a continuously learning system with a persistent identity. The episodic, semantic, and procedural memory split is key. It enables personalization and adaptivity simultaneously rather than one at the expense of the other. And the hybrid storage approach balances neural flexibility with deterministic fact recall. That said, we must be honest about the challenges also. The hierarchical memory is computationally intensive, and uh, poorly managed LTM can become a liability. There's also the risk of decision drift, where the self-editing agents accumulate undocumented reasoning that becomes uh, impossible to audit. And the bias amplification risk is also real. Like, for example, if a user's history contains biased patterns, the system will reinforce them. Ethically persistent memory demands explicit user consent, not just for data collection, but for how the data is also reused over time. And finally, for conclusion, the LTM transforms AI from stateless context processors into personalized continuous learning, ethically accountable systems. The memory augmented agent framework makes three foundational commitments: memory as a first class architectural response, a hierarchical ESP designed backed by hybrid storage, and ethics built in from the ground up, not added as an afterthought. Looking ahead, we see four key directions, which is neuro-symbolic hybrid architectures using knowledge graphs, memory lifecycle management, including consolidation and pruning algorithms, standardized benchmarks like lifelong agent bench for evaluating lifelong learning, and validation in high stakes real world applications like research assistance, tutoring. Yeah, thank you.
Is thank you, Sridhar. A really good, very good presentation. The work is also very good. The only one question for you, it's a MA architecture. Can you give little more explanation about that MMA architecture?
Yes, ma'am. So this memory augmented agent,
Augmented agents.
the agent basically receives the input. It retrieves the relevant past knowledge from the long-term memory, and it then combines it with the current context of for the reasoning. After this, it then generates a response.
What
Uh,
happened?
it then generates a response,
Sridhar?
extracts. Yes, ma'am. Hello.
Yes, yes.
Yes, please.
Yes, ma'am. Am I audible?
Hello, Sridhar.
Hello. Hello.
Yes.
Hello. Am I audible, ma'am?
Yes,
Hello.
Sridhar, audio.
Yeah, Sridhar,
Yes, yes.
please.
Yes. So then after generating the response, it extracts insights from the interaction, and then it updates its memory through the dedicated memory manager. And this enables like a continuous loop for learning and the personalization.
Only this MMR, it's already existing one, or there's some hybrid you have created, it seems. It's an
No, ma'am.
already existing. Mm.
There are other existing frameworks for long-term memory, but this framework I have come up with, and it integrates the episodic, semantic, and procedural memories, which other frameworks do not do as of now.
Okay. Okay. Okay, Sridhar. Good. Thank you.
Okay, thank you, ma'am.
Now I request the next presenter, Abhijit Anand.
Hello, ma'am. Am I audible?
Yeah, please.
Yeah,
Then proceed.
yeah, just a second. Is my screen visible?
Yes, it's visible.
Okay, so good afternoon, ma'am. My project is titled as EmoNav. So it is an adaptive AI navigation framework for visually impaired users via real-time emotional state detection. So introduction about what we're going to say here is like around 2.2 billion people worldwide have visual impairments, and they rely on navigation apps to get around. But the problem is that these apps treat everyone the same way all the time. Like whether you're calm or you're panicking, the app gives you the same amount of information at the same pace. There's no difference anytime. And even when you're like stressed, you know your brain can't handle much when you're stressed. But these apps, they don't really mind, and they just keep on giving you information of how they are trained to do. So that's where our model, that is Emoda, comes into play. It is what if your navigation app could sense how you're feeling at real time, and it can adjust to a way that you'll understand better. That is why we have our model known as Emoda. So the objectives of this model, first one, it is like to build a first of a kind navigation system that adjusts to how a user is feeling in real time. That is one thing. Second is that we have to find a reliable way to test the system on actual users. As of now, this is just a theoretical and simulated study. It's not a real world analysis. Third objective is that we have to prove that this model actually works better than the ones out there in the real world. For example, Google Maps. Our methodology here. So, Emonav is actually a wristband. It's a sensor on your wrist. So it works on two things. One is technology known as GSR, that stands for galvanic skin response. It measures your like sweat from the skin when you're under stress. And the second thing is the voice sensor. It just listens to you and finds out if you're a stressed user or if you're calm at a certain time. Sorry. Yeah. So what this Emonav wristband does is that every 5 seconds, the AI classifies the user state, emotional and physiological state as low stress or high stress. And if the person is stressed, it reduces the information given to short and haptic instructions, that is vibrations and such. And if you're found to be calm, it just it resumes its normal way of letting you know which turn to take, what is there beside you, and where to go. Since we don't have any permission to do this on the real world because we need lots of ethical approvals for that, we've just used a simulated study of 100 virtual users, and we've compared it against three navigation systems. That is, one is known as static verbose, which is nothing but a normal apps like Google Maps. It just tells you information what it's trained to tell you. It doesn't change on anything. Second model that we are comparing this against is a minimal model or a static minimum that is nothing but information is greatly reduced. It tells you most minimal information that you need to know to get to a place. And the third type of model that we've tried here is known as random adaptive. That just switches between extremely informative and completely minimal. It doesn't use any logic, it just shifts between it as and when it likes. However, it is trained to. So based on our result that is from the simulated model, this is how it turned out to be. And Emona has found to be better than the other three apps in all three cases. First one here is navigation error rate. In that, as you can see, Emonav is far better than a normal working app in the current world. That is, it has 11.2 percentage of error rate only, whereas the real one has 17 percentage. And being minimal also doesn't mean that it's better. It still has more error rate. When we check on task completion rate, here also Emonav is significantly better than all the other three models. And when you come into checking about processing overhead, that is nothing but your cognitive load on your brain. Here, it is also found that Immuno has a very less load on your brain, even though minimal, as you know, has pretty much no load on your brain. But in the test, we found out that being minimal doesn't make it any better. So what it means is like giving less is also not good, giving more is also not good, and we should just give the right amount of information based on the real-time user's emotional state. And from our result, as I just told you, we have found out that Imana is much better than all the other three. And a random adaptive, as I told you, it being minimal doesn't give you a lot of information. Telling too much doesn't adapt to a user's state if they're panicking or stressed. And being adaptive, just switching in between, not knowing what the user is like, is also useless. And our conclusion would be that Emanag actually is far better than the navigation apps present in the real world. According to the test, we have achieved 34% fewer errors and 91% task completion rate over the other apps. And this proves that emotional awareness could be a great difference and could make a big, meaningful impact on assistive navigation. So my future plans with this is to actually test with real visually impaired users. And currently, I don't have the resources to make a wristband, but if it was there, would have surely tried it out. So yeah, that is my presentation now.
Yes, thank you, Abhishek. It's good presentation. Just you go to the slide, the methodology slide.
Yeah,
Yeah. Here, what I find here, you have mentioned here, if stressed, no, every 5 seconds, AI classify the user state low or high. Okay, it's
correct,
good. And here you have mentioned two type of wrist sensor and the voice tone in the first point.
right.
Wrist sensor and voice tone. So suppose if wrist sensor is failure or something wrong in the sense, you will the system will find the about the stress level only through the voice tone,
Correct.
right? So if sometimes voice tone is not there, if the wrist is there any message or a thing will come if voice tone is also not there, wrist sensor is also some problem, then is it easy to find out that particular the signals or something wrong, that like that you can understand is there any message it will produce or not?
Ma'am, just like you said, we have not gone that deep into it. As of now, as we know, even the wrist sensor, not everyone needs to sweat in a situation of panic. And not everyone's voice will tremble when they're scared or afraid. So
Okay.
as of now, we have chosen this sensor and voice tone because it is one of the major reasons or no, or major thing that we can see in a stressed or panicking individual. That is
See,
why we
that
have chosen.
you suppose if both are working, the is the results you what you got is true, or you find the exact whether they are in a stressed or calm, you got the correct results.
Yes, it's a correct result.
Okay. Okay, ma'am.
And
Thank you.
this thing we have actually, since we couldn't use real data, I've checked over the internet and I found that there was an experiment conducted before on 15 people.
Oh,
And they use the same thing. It is known as WESAD. It stands for wearable stress and wearable stress and something detection, ma'am. I'm not
okay.
sure, but it was a publicly available
Suppose if you go
scientific experiment.
into deeper, then you can find if anyone is failure, something should the message or something should come, right?
Right. If I can
Yes.
go deeper into it, if I can test on real people, we can find out where it can be better.
Yes. Okay. Thank you. Thank you, ma'am. Thank you so much.
Thank you, ma'am.
Now I request the next candidate, Vidya Shri.
Um, Hello. Is my screen visible?
Yes, it's visible.
Yes. Okay. So good afternoon, everyone. I'm Vidya Shri. I'm currently pursuing MCA at Christ University. My research is titled Geospatial Mapping of Menstrual Deserts and School Dropouts Among Adolescent Girls in Karnataka. So, moving to the introduction, this research addresses menstrual hygiene management as a critical yet often ignored factor in educational continuity. The problem is that for many girls in Karnataka, getting your period means the end of education because many schools lack private toilets, clean water, and sanitary pads. Girls often stay home for several days, let's say 5 every month. Over time, they fall so far behind the syllabus that they eventually end up dropping out of school. My research introduces the concept of menstrual deserts, which are basically the districts where the combination of insufficient school infrastructure and low household awareness forces girls into absenteeism and eventual permanent dropouts. This creates a barrier to a girl's future. While Karnataka has been raising awareness, there are still unfair differences in access to sanitary products and wash facilities. WASH stands for water, sanitation, and hygiene facilities. By mapping these menstrual deserts, my research provides a way for the government to see exactly where the infrastructure is failing, moving the conversation from a generic health issue to a specific infrastructure and policy problem. This research is framed within the SDG goals 3, 4, and 5. So, moving on to the research objectives, the focus is on four major goals set to solve the problem of school dropouts among adolescent girls. So, here my target girls, like adolescent girls, are between the age of 15 to 19. So, the first objective is to find these menstrual deserts to locate the specific areas in Karnataka where girls have the least help with respect to their periods. The second objective is to come up with a composite index, which is basically a scoring system to build a fair score for every district that looks at both their life at home as well as their life at school. The third objective is to analyze the dropout correlation to prove that there is a connection, to use math and to show that where there is less help, there is more dropout. The fourth objective is to finally put it out as a visualization, put it out on the map, to do a color coding thing and show it to the government saying this is where we need help, this is where people are suffering, and this is where more supply and money is to be sent. So, coming to the next part, that is methodology, the data integration framework. To get a full picture, I've integrated two major government data sets. The first one is the National Family Health Survey, that is NFHS 5, which provided the household component data on things like family literacy and use of hygienic protection. Second, I've used the Unified District Information System for Education, UDI-SE Plus, which covers the school component data, including the status of girls' toilets and dropout rates. Both cover the 2019-2021 period. This is the maximum updated information that I could fetch from all of these. So, as I'm showing in this slide, these are the mails that had to write to a particular government officer and get the data sets because it wasn't available like publicly. So coming back to the data cleaning phase, there are basically 30 districts, and since the data came from two different data sets, the naming wasn't like the same everywhere. Like in one of the data set, it was Bangalore urban, and in the other, it was Bengaluru urban. So I had to standardize all of those names. And I have also performed one-on-one inner join. So only the districts that is present in both the data sets are present over here. So while I received the data set as per the mail that had written, each of these came as 30 different PDFs because there are 30 different districts. And these PDFs, like, they were like full, beautiful with all UI, and they weren't like properly structured in tables. So I had to manually copy paste all of the data and put it in an Excel sheet. Again, I did try using OCR, but it did not really help me because these were all sensitive values and I couldn't take a chance with it. So after this, finally, I incorporated geospatial data using the EPSG coordinate system. This is the coordinate reference system used for the Karnataka's districts shapefile. It is essential for creating choropleth maps. This is basically to show color-coded maps as it highlights the geographic boundaries. This way, the government or the reader who is reading it can know which districts need help with respect to menstrual deserts. Coming to the main part of the research, that is the composite menstrual index construction, I developed this to quantify the total menstrual support environment for each district. This index is a weighted average of two main components. The first one is the household component, which have given 60% weightage. It measures foundational factors like female literacy and home sanitation, whereas the second one is the school component, which has 40% weightage and measures the direct infrastructure girls use daily, such as functional toilets and pad distribution. Over here, the reason I've given 60 and 40% is because most of the times everything starts at home. So, hence the what do you say, maximum weightage to household component. Another key point to notice over here is the inversion of the dropout rate. I've subtracted it from 100 before adding it to the index. This way, when you add it to the index, when the actual dropout rate decreases, the CMI value, the index value increases. That way, we can say that CMI value is higher where the dropout rate is lower, and hence it comes under a safer zone, else it would come under a menstrual desert. So, to determine these specific classification thresholds, I looked at the statistical distribution of the CMI values. Over here, the scores for like 30 different districts. The scores are ranged from a minimum of 55.5, that is Chikballapur district, to a maximum of 79.7, that is in Uttara Karnataka. I used quantiles to divide these districts into three equal groups of 10 districts, because there are 30, so three equal groups and 10 districts. The first group is the safe zone, the second one is the transitional zone, and the third is the menstrual desert. The 66.1 value represents the cutoff point where exactly one third of the districts fall. Any district scoring at or below this classified range would come under a menstrual desert. The next is 72.6. Any district scoring at or above this is called as a safe zone, and any other one that comes between these is called transitional zone. So that statistical split ensures we have an even distribution of 10 districts per zone. This way there is fair comparison. So now coming to the results, the geospatial distribution of menstrual deserts. Looking at this, when we plot the CMI on the map of Karnataka, the pattern that we have on the left side appears. We have two maps over here. The first map is basically CMI values with a gradient of all like the values, and the second one over here is basically I'm classifying the districts into three categories. One is menstrual desert, safe zone, and transitional zone. So now the menstrual deserts shown in red are clustered in the north and east. These districts led by Chikballapur with a score of just 55.5 face the highest dropout value rates in the state, averaging to 13.7%. In contrast, the safe zones, the green areas along the coast and central west, show much stronger support systems, with Uttara Karnataka achieving a top score of 79.7 and a dropout rate of only 4.4%. This map works as a priority list for the government. It can improve the support that it is giving to the desert zone to match the safe zone. We can see that by following the same things that it is doing for the same zone, it can improve its dropout rate by at least 4.6% across these high risk regions. In the next slide, as we have a look at the key statistical findings which provide the proof for my study, we can observe that girls in menstrual deserts face an average dropout of 13.7%, while those in safe zones have a much lower rate of 9.1%. There is the reduction potential of 4.6 percentage, which can be a primary target for the policy recommendations. Technically, our correlation analysis confirms that with a Pearson's correlation value of minus 0.39, this result is statistically significant, meaning we can confidently state that higher menstrual support leads to a lower dropout rate across the state. The index scores vary significantly. As I mentioned in the earlier slide, it varies between 55.5 to 79.7, showing that while the average support rate is 69.1, the deserts are lagging nearly 14 points behind the safe zones. This data transforms the conversation from a general health issue into a precise, measurable challenge for school infrastructure. Next brings up the most critical insight of my research, that is the infrastructure gap. People usually say that Building more toilets will slowly solve the dropout crisis. However, my statistical analysis has shown that these individual factors, like functional toilets, almost have no correlation. The value over here is 0.033 with respect to the dropout reduction, hence, actually, no correlation. To truly support educational continuity, we need a holistic approach. We must bridge the 20% point gap that currently exists in sanitary pad distribution between our safe zones and our deserts. My research demonstrates that it is the systemic support, the combination of pads, functional facilities, and household awareness that determines whether a girl stays in school or drops out. The next slide basically works as a call to action of my research, that is transforming the data into a concrete plan for the Karnataka government to reduce school dropout rates among adolescent girls. Here are the 4 things the government can implement based on my research. These are the suggestions. First is the priority district intervention. Have identified specific geographic hotspots like Chikballapur, Kalburgi, Bidar, Chikmagalur, and Mandya that require immediate high intensity resources because they have the highest dropout rates and the lowest support rate scores. Next is the integrated service delivery. Because individual infrastructure had almost no correlation with dropout reduction, I recommend combining physical toilets with maintenance, hygienic education, and community awareness. Next is the supply chain investment. The state must bridge the 20% point coverage, a gap in sanitary pad distribution between safe zones and deserts through sustained funding and reliable distribution networks. The fourth one is the annual monitoring system. By adopting the CMI, the state can move districts from high risk desert status to safe zone status over time using a dynamic data driven tracking tool. In conclusion, in short, my research proves that we cannot just build a toilet and expect girls to stay in school. It takes a full package of support, sanitary pads, clean water, and educated families to make a real difference. By using the map and the scoring system I've created, the government can stop guessing and start sending help exactly where it is needed. This isn't just a project for Karnataka. The same scoring and mapping method can be used to help girls all over India stay in school. Thank you. And any questions?
Thank you, Ma. Thank you. So very nice presentation. The work is really so good. But only thing, you got approval from the person or some higher authority for
Yes, yes.
collecting the data, right? So have you
Yes.
submit the report of this?
No, ma'am, I did not.
Then you should the report. Then I thought that final solution also expect from the government based on your project.
I mean,
Is if
okay.
everything is
Yes, yes. I will share it with them after this.
yeah, the report you support to submit, then only we will get some improvement in other schools, right? Where
Yes.
you have mentioned some government schools. You have how many districts you have selected?
Ma'am, 30 districts. It's specifically in
30.
Karnataka.
Yeah, 30 districts. Then each and every district you have lot of schools, no?
Ma'am, I haven't gone through each school in particular. I'm only looking at the districts or overall.
Okay. Totally, how many schools you have collected?
Ma'am, it's not about schools, but it is all about the districts. Like we have 30 districts, and that is how I've
Okay.
listed it out.
Randomly you selected, especially
Not,
the
no.
educational.
Karnataka has 31 districts. Out of that, I did not have data for one district, so I've only done it for 30 districts.
Okay. So randomly you have selected the schools or some education from that particular
No, ma'am.
district.
I can show you the data. 1 minute. I can show you the data set.
Yes.
Just a second. Okay. So this is the implementation that I had made, and this is the files that I'd worked on. So for each and everything, like I had got the district files and everything. So you see, so these are the kind of like data that I got. So Bangalore,
Uh,
Bidar, then Bijapur, then for each and every district I got it. So I had to convert it into an Excel file and then had to do my analysis. So this is the analysis that was made.
okay, good. But better you can submit the report to the person, higher authority, so where you received the
Mm-hmm.
approval or something permission. That will be good.
Yes, ma'am. I'll do that.
Okay. Yeah. Thank you, Ma. Thank you so
Thank you,
much.
ma'am.
The next candidate, Megha.
Yes, ma'am.
Megha Ulas? Yeah.
Yeah. One minute, ma'am. My PPT is not
Yes,
visible.
yes. Yes, no problem. Yes.
Is my screen visible, ma'am?
Yes, yes, yes.
Okay.
You can
Good
start.
afternoon.
Yes.
I am Megha Ullas from Christ University, and my project is personalized diet recommendation using machine learning. So, before I begin, I would like to briefly outline the motivation behind this project. Conventional dietary recommendation systems are largely generic and do not adequately account for individual variability. In practice, nutritional requirements differ significantly based on factors such as lifestyle, dietary habits, and underlying health conditions. This creates a gap between general dietary guidelines and personalized health needs. The proposed system addresses the gap between leveraging machine learning to develop a data driven framework for personalized and medically aware diet recommendation system. So, introduction is normally conventional dietary recommendation systems are largely generic and often fail to account for individual variability. In practice, nutritional requirements differ significantly across demographic, behavior, and clinical factors. Additionally, many existing approaches do not adequately incorporate medical constraints into dietary recommendation. It creates the need for data driven and personal diet recommendation frameworks that can provide more relevant and practical suggestions. Like normally, most dietary recommendation system follow BMI. Here, I'm not using BMI because if we use BMI, it is not that personalized. So here I'm using micronutrients, health factors, and dietary preferences as the main for diet recommendation. Objectives. The objective of this work is to design a personalized diet recommendation framework that integrates user demographics, nutritional information, and health conditions. The system applies supervised machine learning techniques for meal classification and evaluates multiple models to identify the most effective approach for recommendation. System architecture. So it is a simple version of the system architecture. So here the data input is age, gender, height, weight, and activity level, dietary preference, which is like vegetarian, non-vegetarian, calorie and nutrition target, diseases such as diabetes, hypertension, etc. These are the main things we are focusing on. So this slide presents the overall system architecture of the proposed framework. The system begins with the user profile and nutrition input, including demographic attributes, dietary preference, and disease conditions such as hypertension. The data is pre-processed through encoding and normalization techniques to ensure consistency. Feature engineering is applied to derive meaningful attributes such as BMI, nutrition-based meal categories, along with disease-specific constraints to ensure medical relevance. The processed data is then used to train the multiple ML models, where I have selected random forest for the final project because it was giving more accuracy and it is giving more correct answers compared to other models. Finally, the system generates a personalized meal recommendation where we'll get a breakfast recommendation, recommendation, dinner, and snacks, which aligns to our health constraints and our dietary guidelines. So the data set is used in this in the study consists of like 1698 user profiles with multiple dimensional features including demographic, nutritional, and clinical attributes. It also includes meal suggestions across different categories like breakfast, lunch, dinner, and snacks. A key challenge observed in the dataset is the dataset is highly imbalanced, where certain categories are significantly more represented than others. This imbalance directly affects model learning and prediction performance. To address these issues, I have used SMOT or synthetic minority oversampling technique as applied during model training to improve the performance of underrepresented classes. Feature engineering. Feature engineering here plays a critical role in enhancing the model performance. In my work, BMI is derived from height and weight to better represent the body composition. Meals are categorized based on micronutrients distribution into categories such as high protein balanced, low carbohydrate. In addition, disease aware dietary constraints are also incorporated. For example, low sugar for diabetic people and low sodium for hypertension people. These transformations ensure that the recommendations are not only data driven but also medically relevant. Finally, categorical encoding and feature scaling are applied to prepare the data for machine learning models. So the data was split into training and testing using 80:20 ratio with stratified sampling to preserve the class distribution. Class imbalance was handled using SMOT and features were normalized using standard scaling techniques. 4 machine learning models were evaluated under consistent conditions, namely I have used decision tree, random forest, support vector machine, and multi-layer perceptron. So the model performance was assessed using the standard evaluation metrics such as accuracy, precision, recall, and F1 score. Results are the site presents the side I'm giving the performance comparison of the evaluated models. Random forest here you can see has achieved the highest accuracy of 74% and demonstrated the best balance across position recall and F1 score. MLP and decision tree showed moderate performance compared to SVM. Due to the complexity and non-linear nature of the dataset, it is why the accuracies are less compared to other one, but mostly random forest was preferred. This highlights the robustness of ensemble models in handling such data. Based on these results, random forest was selected as a final model for generating personalized recommendation. So here we are going a deeper analysis of the results that indicates that the model performs well on majority classes where sufficient training data is available. However, performance is reduced for minority classes due to data imbalance. Confusion metrics here, we can see that most correct predictions are concentrated along the diagonals, while misclassification occur across certain categories. Additionally, SVM shows high precision but lower recall, indicating a bias toward the dominant classes. Overall, these findings highlight that class distribution significantly impacts the model performance even after applying SMORE, and improving data balance could further enhance the results. So, conclusion and future work. So, in conclusion, this work demonstrates the machine learning can effectively support personalized diet recommendation by integrating nutritional and medical constraints along with evaluated models. Random forests achieve the best performance, as I said earlier. The proposed framework shows strong potential for real-world application in healthcare and nutrition. Future work, I will be focusing on expanding the data set and incorporating different multiple cuisines from different parts of the world. And I would like to use a real-time user feedback for deploying the system as a scalable application. Thank
Okay.
you. Any
Thank you,
questions?
Meka. I'm Dr. S. Mogna is along with me. She'll asking me questions. He has some doubts. It seems. Okay.
Okay.
Hello, Meha.
Yes, ma'am.
Yeah, this is very important topic for nowadays, right? So regarding health, and I need to one answer one question. Did you
Yes, ma'am.
compare to any algorithm for this? You didn't say any comparison at all, right? You directly implemented to the that random forest, right?
I have used multiple ML models and compared them, as you can
Oh,
see here.
okay.
And from this, random forest was performing best amongst these. It's like,
Okay.
as I
How?
said earlier, the data set is highly imbalanced and it's quite small. If it is a bigger data set, we can move into deep learning and use better options. But right now, due to the data set constraints, I'm using random forest.
Okay, fine. But one more question is, how much data have you implemented for this research?
Sorry, I didn't get it.
How much data you have implemented for this uh, analysis?
How many records? How many data?
So this, I have taken this data set. It is available in Kaggle and it has around 1,500 or something. But as it is imbalanced, I have to remove some of it. It has
Okay,
exactly, I think, 1,698.
okay, thank you.
Thank you.
Thank you, ma. Thank you. So now I request the next candidate, Prapanchana.
Yes, ma'am. I'm just presenting my screen.
Yes.
Is my
Yes.
screen visible?
Yes.
Okay. Hello, everyone. I'm Prabhanjana from Christ University, currently pursuing BSCCS. So, my paper is titled Mapping Urban Shade, a Scalable Remote Sensing Pipeline for Urban Green Infrastructure Quantification. So coming to the problem statement, you know how every time we see news and reports of how urban green cover or urban forests are decreasing or increasing. This is somewhat related to that, but these studies look at a city as a whole. You know, but what I'm looking at is road level tree canopy. So why road level tree canopy matters is, you know, people usually when they're traveling from place to place and they prefer to walk, they're walking on these roads which don't have any shade or anything, and especially in summer times, this leads to higher cases of heat stroke or other such causes. Uh, and a thermal comfort determines actually walkability, and we know how Bangalore suffers from traffic and stuff. And if we want to promote walkability and all of these things, we need to ensure this thing exists. Also, the urban green cover also reduces something called heating island effect. So this can also bring down temperature across the city instead of just in specific heat specific spots, like how we have trees in Kaban Park and such. So this uh, through this analysis, I have also found out that there is a 0% road canopy score. So I'll explain what that is and how I've come to that conclusion in a while. So how I've this is my research pipeline or methodology. So what I'm doing is taking satellite data from the Sentinel-2 and computing something called an NDVI score. This is a general vegetation index score to understand how much green cover is in a city. And then I'm also using the road segments of the Bangalore. I'm creating a 25-meter bilateral buffer around each of this. So I have around 1 lakh road segments downloaded from open source websites like OpenStreetMaps. And with this, I also have uh, a calculation score to calculate the RCS or road canopy score. And this is what I'm using to perform my analysis. So coming to how I'm computing these scores. So the road canopy score is looking at a road segment, looking at how much of this road segment is covered by vegetation, and how I'm determining if there is vegetation is if the NDVI score is greater than 0.4. So 0.4 is correlated with trees with canopies that can provide this buffer, and I'm concluding that the road segment is a valid valid road cover if the RCS score is about 10. So that means if the road has more than 10% of the road segment with a shade. And I'm also proposing something called a Ward Green Mobility Index and the root canopy quality. So both of these follow the similar formulation, but they're used for different things. So Ward Green Mobility can be used by when someone is trying to improve the ward within the city. And route canopy quality is something that can be used within our routing systems like Google Maps and Apple Maps. So if someone is choosing to walk from destination A to B, instead of just suggesting the shortest route, it can also include urban shade so that thermal comfort is considered while determining a walking route. So coming to my analysis, with the computed scores, you could see that I have a RCS score and also the district-wide canopy scores. So through my method, I had a total green cover of 27% across the city. And this includes everything. This closely aligns with the IISc studies, which said that there's almost 26.3%. So this is more or less also validation of my methodology. But coming to the actual part of the paper, which is the road canopy score, we can see that the road canopy score is 3.85%. That means out of all the roads in Bangalore, only 3.85% roads have a substantial amount of green shade. And this is a very low number. WHO standard says that at least 10 to 15% of a city should have this score. And coming to median RCS, which is 0%, which is a very staggering score, which means that almost all of the roads within Bangalore have no tree shade at all. Uh, and these are very jarring results for a city like Bangalore, which is used to be known as the Garden City of India. So, what are the implications of this? So, if we have to reach the WHO targets, there needs to be at least new trees planted across 10,000 kilometers of road corridor. We can see with different road widening or metro construction, a lot of these trees are being cut. While they're saying they're being planted elsewhere. They're not replenished in the places they've been taken away from. So the urban island heating effect is increasing. So increasing the average temperature of the city and also leading to more issues like heat strokes and such. So yeah, and coming to also some of the limitations of my methodology, Sentinel-2's satellite has a 10-meter resolution. So if we have streets smaller than that, it might not converge as neatly as we would like to. I was only able to extract this through one season, which is the dry season of March 2024. While this wouldn't affect large trees, which we are considering for the tree canopy score, it would be ideal if I could uh, access multiple satellites and use data from multiple timelines and have an average instead of one thing. So these were some of my limitations. So just coming to the conclusion, highlighting key things. Only 3.85% of Bangalore's 15,000 kilometer road networks have meaningful tree canopy, and the median is zero. This is a very alarming score, and it needs to be brought forward. Uh, and dense tree canopy is just 2%. So this needs to increase highly. So we need more targeted tree plantation drives and all such things. Uh, in the future work, something that I suggest is including it into mobility standards like Google Maps and Apple Maps when they are considering this route planning to consider tree canopy too. And coming to my how this could be improved upon the future, we could use a better satellite imagery or across a larger time frame so that the uh, scores that we get can be more granular. Thank you.
Thank you, Pravanchana. A good presentation, but actually, it's a very beginning level, it seems. Still, you have to go for deeper into this research. So, I think it's like that only. Anyway, you have
Yes,
started a good start. Thank you.
yes. Thank you.
Thank you, sir. I just conclude this session.
Madam,
So,
please discuss me,
Excuse me,
madam.
ma'am.
Madam,
yes, sir.
madam. So one more candidate are there, madam. Sorry for
Only
your disturbance.
Pravanchana, the
Next,
last.
Mariam,
Good afternoon, ma'am.
last meeting.
Okay, okay,
Uh,
okay, you can start.
Ma'am, I'm very sorry, ma'am, because my exams got extended, so I couldn't attend the morning session. Is it
Okay.
fine if I continue, ma'am?
Oh, yeah, it's no problem.
Okay, ma'am. Just give me a second to share my screen.
Yeah, you just share your screen.
Can you hear me, ma'am?
It's able to hear me.
Just,
No problem. You can proceed.
okay. So good morning, good afternoon. And my getting into the topic, mine is AI enhanced emotion analysis questionnaire response with the help of visual normal gaming. So getting to why I chose this topic or why I focused on this is, let's focus on the main problem. If you see that even India's population has about like 15% with facing mental health issues, and they have like a particular stigma in terms of seeking help. They consider it such something that they feel that it should be like a disorder. They should not seek help and all. And we found out that traditional methods, like for example, psychologists or psychology departments usually send these kind of surveys or standardized surveys with questions, and they have a set of options, which is usually sometimes it's some of the questionnaires are said to be very intimidating and impersonal, or sometimes it feels very cold, and there's very low engagement response. So, for the sake of just completing the whole Google form or whole this one, they're trying to finish it up very fast. So at the same time, you wouldn't know whether the person is really engaged with that particular questionnaire or survey, and you won't be able to get a conclusion. So what I came across is, after looking at this, I thought, why not create something that would engage the person who's filling those Google questionnaire forms, and try to have an engagement process between the user as well as the survey given. So we took the questionnaires and we tried to develop a story around it. So you have like a particular narrative. In that narrative, we made it in a game based format. And in that game based format, we added like an AI based model. And that model takes your choices, what you have made, and it gives you an analysis in the particular website. And that's how the psychologists be able to analyze. And after finding out, getting to the research objectives, as I said about the reducing mental health stigma, and we embedded the questions in the narrative. There was also, we have provided a separate website for like the AI based behavioral patterns, which can be used by the psychologist or psychiatrist to have their own analysis and for their own use. And So these are the research objectives. For the methodology, what we use is as the player logins, they play the visual novel game. The choices are recorded through the Firebase. So each choice is sent to the Firebase code. From the Firebase, it gets changed to the website. And based on rule-based engine, we are able to get their emotional patterns. From the we have chosen, as you can see, we have taken existing modules. I've given a table. So if you see that previous games have like very limited features, they have UI problems, but I've noticed that not there's not single game till now which has implemented AI based choice in terms of finding out what their emotional capability is. So once that was done, is we took the for context, the PHQ is the questionnaire, physical health questionnaire, and we have taken that into consideration, and we have tried to take those questions and develop the story around it. And with the help of psychology department, we are able to, and we've also used a specific API key, which that API key we have tried to connect it to the website, so that and we have given a specific constraint. So the constraint is depending upon, suppose the user chooses like choice 1 or choice 3 in a different order format. So each order formats give you a specific stress tag, and it's able to calculate your decision points. And this was based on the rule-based classification model. For the experimental design, since we have not fully completed the project, we have done a prototype. In that prototype, we have basically done the game system as well as the AI system separately, but it's connected to a pipeline. That is the only kind of flaw we had. And we found out we took about 15 participants, undergrad, not necessarily undergrad, like from 18 to 24 age. And we asked them to fill the questionnaires in one format, like a paper format. And we asked them to play the whole game, but in a more interactive format. And we found out that people who fill the questionnaires, about 80%, they prefer the game format compared to the traditional format. If you see traditional format, their attention span is quite less. They just want to finish it fast, even though it's maybe say about 25 questions or something. They try to finish it fast in 15 minutes, and but at the same time, they feel that it's not. They don't feel like the need to finish it to actually sit and read about all those questions. But it's quite the irony that in the game format, if you see that 80% prefer the interactive game, usually the interactive game is 20 to 25 minutes, but sometimes it extends about to 1 hour. And it's very surprising that they're able to have the attention span for so long. And from the analysis, what we did was 80% preferred the interactive game. 13% did not prefer the game. There was no particular preference, and the 6% preferred the traditional format. And all of them completed the game. There was no like particular dropouts in the middle. And these were the 4 kind of patterns with tags that we took into consideration. And depending upon these 15 people, we found out that these tags, based on the choices what they selected in that particular game, these were the percentile what we got. And in terms of discussion, what we did was, as I've explained before, we have used AI-based validated tags by the psychology faculty, and we have used the game format. We try to assess their particular narratives, what they've chosen. And we've also created a vent system. So a vent system is basically like a platform. It's anonymous. You try to vent out your whatever feelings or express any emotions anonymously with security maintained. And in terms of scalability, we have used the Firebase or the online NoSQL database, and we have tried to collect all the information from there and put it into the website. Before I go into the conclusion, I might as well show the screenshots. These are the screenshots of the game. And this is the vent box. These were the vent channel that we created. If you can see that some of them are, in terms of privacy, they're able to block whatever they want to not show. And for the website, which I'm going to show, is this is the mental health dashboard. So the 15 participants we have taken, and we have created bar charts and graphs so that the psychologists be able to have a visual outlook of how these 15 participants actually played the game and what choices they selected. And we have also, since for anonymous sectors, we have tried to use this as P1, P2. I've not mentioned their names, but their names are present in the Firebase for our reference. And we have done a pattern. So it particularly, we have connected the API key to here, and we have asked them to generate a response, a report kind of situation. And we have got the report. And this report can be able to use by the psychiatrist in terms of their own study or own understanding. So in that way, in terms of the game I can show you how it works. So we have made the game with all the UI in Unity engine, and it's a 1 hour process game. So you will have messages popping up here, and we'll be able to, once they play the whole game, all the choices get selected here, and we are able to analyze it. So in terms of the conclusion, give me 1 second, ma'am. In terms of the conclusion, we are trying to show that interactive storytelling can be help in use in terms of engagement, in terms of this psychology department or traditional formats can be used in terms of engaging participation. So I feel that if we can embed this mental health questionnaires in a visual novel format to create narratives, you're not only implementing one single department, you're implementing the computer science department as well as psychology department, arts department, and you're giving an opportunity for everyone to work on a single format. At the same time, the rule-based classification engine was helping us. I mean, as of now, we don't have like particular clinical diagnosis because I'm not part of the psychology department and I don't have the kind of permission to be able to go deep into the format. But we have taken the surface level questionnaires which were given by the department, and we have done based on the rule-based classification. We are able to get the 5 emotional dimensions, and we're able to prioritize the user safety and try to get an analysis format. So all the at the end of the day, all the research what we have done is basically anonymized. So we are giving comfort. So the basic change is that in the older formats, there's always the stigma trying to whether my name will be posted anywhere or something like that. But in this one is anonymized. So you're an anonymous user. So in terms of that, we have created a dashboard which provides the psychologists with like a population level behavioral insight. So they'll be able to have that kind of analysis which is easy for them to use. So that's the end of my research.
Thank you so much, Mariam. So very good work at present. And nowadays, this is the main part in this world, like, especially the childrens and many even elders also affected. So it's a good thing only. But do you have any idea of improving this?
In terms of now, we don't have like a particular format of proving because we have done an informal research. Since I've done a prototype for the game, it wouldn't be right for me to take a proper official procedure. We have to finish the game, then only I'll be able to take the proper
Yes.
procedure. But we have taken an experimental, like we have taken an informal session and made them sit and actually play the game.
Okay, ma'am. Thank you. Thank you so much.
Yes.
Okay. Now it's time to conclude the session. Really, I enjoyed all the presentation, each and everyone different angle and different aspects of the research. Really, each and every presentation was good. I congratulate all the presenters. Each and everyone gave me a good insights of getting into the field. So really, it's a good, and this is the time to thank the organizers also, especially Dr. Karthikeyan and other team members, those who are behind the organizing this particular conference. Really, it's an enjoyable, and I once again my hearty thanks for the opportunity given to me to see all these kind of excellent researchers. So thank you so much, sir. Thank you, everyone.
As we come to the end of the international conference on smart infrastructure and sustainable development and engineering, ICSISDE 2026, I would like to thank the morning keynote speaker, Dr. Hemlata Madam from Sri Ramakrishna Arts and Science College, Coimbatore. Thank you, Madam.
Thank you, sir. Thank you so much, sir.
And I would like to thank the session chairs, Dr. Davamani Madam for the morning session, and now Dr. Hemlata Madam and Dr. Mohana Madam. Thank you so much, ma'am.
Thank you, sir.
So thank you for this opportunity, sir.
And I would like to thank the presenters and participants for making this conference a grand success. The research papers presented today highlighted important innovations and research findings in artificial intelligence, machine learning, cybersecurity, smart agriculture, healthcare, and sustainable development. I hope this conference provides a platform for knowledge sharing collaboration, and research development. I now request all participants to share your feedback. Participants can share your feedbacks. Now this is the feedback session.
Okay. So any participants, if you are willing to share your ideas and thoughts, if it is possible.
Excuse me, sir.
Yes.
Is it possible if I share the feedback? Yes.
Please, sir.
From the session, the entire session as a presenter, I found out different types of projects from different domains. So I was able to have that kind of understanding of the knowledge. I could gain knowledge from each domain. So that was very interesting for me. And in terms of the Dr. Hemalata, she was asking questions regarding our projects, and we were able to find out our flaws as well as try to improve on that particular format in terms of our research. So that's the thing what I took away from this conference. Thank you.
So thank you for your valuable feedback. So
thank you for your feedback, ma'am.
Yes. So one more.
Okay, sir, you carry on.
Yeah. Thank you, sir. So we are preparing the conference proceedings as a world standard. We are bringing the conference proceedings submission to the prestige database such as Web of Science and also Scopus indexing. So and also meet the standard proceedings indexing database also. So all the participants, moreover, you have to submit your paper quality in standard. Sure, we will submit to the Web of Science indexing and also Scopus indexing. I thank to the department faculty of Christ University for the submission to their papers in our conference. Surely we bring into the submission to the database such as Web of Science and Scopus. Once again, I confirm the things. So thank you, the session chair, and also contribute the keynote speaking in morning and afternoon session act as a session chair, Dr. Hamalada ma'am. So I express my sincere thanks to Hamalada ma'am and also Mohana ma'am for sharing your valuable time in our conference. Thank you, ma'am.
Thank you, sir. Thank
you, sir.
And I also express my sincere thanks to Davamani madam also, and especially thanks to Narasimhan sir for supporting and timely help to arrange this events is successful manner. And also express my sincere thanks to the Mahendra Pandin sir, who is act as a conference moderator. He is moderator of all our conference. So thank you, sir. Thank you to comment and act as a conference moderator.
Thank you, sir.
So carry on, sir.
Thank you, sir. Thank you so much, sir.
And finally, we thank you all. Have a wonderful day.
Thank you.
We request you to kindly leave this session yourself. Thank you all. Have a nice day.
Thank you, sir.
Thank you, sir.